Hello U12s and welcome back to mathematics. In this video we're continuing with our new topic of continuous probability distributions, and we're looking at the cumulative distribution function. So this is on page 14 of your booklet. So let's have a look at what the cumulative distribution function is. Now, a cumulative distribution function, it's big F of x here. Now, if you remember when we looked at integration, big F of x is just what happens when we integrate a function. So that is what we call the primitive from integration. Now, this is the signed area function. So here, and below, we have P of big X, so the random variable is less than a score, x, is equal to big F of x, so the primitive, and that is just the integral from a all the way up to x of my function t in dt. Now, what this actually means is when I integrate my probability density function, which we looked at last lesson, that gives me the cumulative distribution function. What this is if you have a look at this part here, that is the probability of all the scores up until the score small x here. So this is, I'm just going to write a quick definition. This is probability of all scores up to x. And so that's what a cumulative distribution function tells me. Just like we did when we talked about in the last topic, cumulative frequency. That's the sum of all the frequencies up until that point. What we looked at in the last lesson, cumulative relative frequency, all the probabilities up until that point, all the relative frequencies up until that point. So with here, what we need to actually do is integrate our function, our probability density function. Okay, so let's have a look at this example here. The probability density function f of a random variable x is given by this following formula. So here, this is the formula that tells me the probability density function is given by x plus 1 over 12 for this given domain. So that is the domain of allowable values that they have here. So this is all of the possible outcomes between 0 to 4. And otherwise, it's just equal to 0. Okay. Find the value of b such that the probability of x, the random variable, being less than b is equal to 5 over 8. Okay. If I just use the definition up above, what I'm going to do here is if I want to find p of the random variable being less than or equal to b, that's just going to be, if you have a look, the integral of a all the way up to x. Now, a is just the lower boundary of my allowable value. So here, that's just going to be 0 all the way up to b of my function x plus 1 over 12 dx. Okay, so let's just figure out what this is equal to. So I'm just going to integrate this like we normally would with integration. So I'm going to actually pull out the 1 over 12. So this becomes the integral of x plus 1 dx from 0 to b, and this is a definite integral, by the way. So here I've got 1 over 12 x. When I integrate this, I get x squared over 2 plus x 0 to b, and so this just becomes 1 over 12 half b squared plus b. Okay, now I'm just going to I'll just leave it like that. Actually, I'm going to leave it like that. Okay. Now, what's the next part of this question? Well, we're not quite done yet. What they tell me is that we know that this value is equal to 5 over 8. So here, I'm just going to solve for this being equal to 5 over 8. So I've got 1 over 12 half b squared plus b is equal to 5 over 8. So let's just start simplifying this stuff. So I'm going to actually just multiply the whole thing by 12. So on this side, I'll get half b squared plus b. So by multiplying it by 12, I get rid of that 1/12 at the start. Multiply that by 12, I get, oh, hang on, let me just check that. That should be 3 over 2. So this is 15 over 2. And then multiply by 2 in front of that b squared. So I get b squared plus 2b is equal to 15. Okay. Now I want to find the value of b. So all I need to do is just start to solve this. So here I get b squared plus 2b minus 15 is equal to 0. And we can just solve this as a quadratic. And so b plus 5, b minus 3 is equal to 0. So therefore, b is equal to minus 5 or 3. Now, it can't be one of these values So we want to figure out which one of these values it is. So if you have a look at the question, it tells me that x has to be between, my score has to be between 0 to 4. So one of these is not going to be allowed. So which value is not going to be allowed? Well, it can't be -5 because that is not between 0 to 4. So I'm going to write here, therefore, b is equal to 3. So that's how we solve these questions with a probability density function. We're just integrating from the lower value of our allowable values, so our scores, up until whatever score they have inside that particular point. And that actually helps me find the cumulative distribution function. Okay, let's have a go at another example. The continuous random variable x has a distribution with a probability density function given by the following. So here, this is our function again. So here, f of x is equal to, this is the function from 0 to 5, and otherwise it's not going, otherwise it is going to be, otherwise it's going to be 0. Okay, where a is a positive constant. Okay, the first part, a, is we want to find the value of a. Now, from last lesson, in what we said was in order for our probability density function to be a valid probability density function, the integral over the whole domain needs to be equal to 1. So what I need to do is I need to integrate from 0 to 5, and if I integrate from 0 to 5, that needs to be equal to 1. So I'm going to say here, the integral from 0 to 5 of ax 5 minus x dx, that needs to equal to 1. Okay, I'm just going to pull out the a at the front, and I'm going to expand this, so I get 5x minus x squared. I'm going to integrate from 0 to 5 again, and that's still equal to 1. And so here, I'm just going to do that my integration and sub my 0 and 5 in. So here, when I integrate this, I get 5 over 2x squared minus 1 over 3x cubed from 0 to 5 is equal to 1. And so I just sub my values in here. When I sub in 5, I end up getting, I believe, let me just check what I've got here. That's 100, and so here I got a times 125 over 6 is equal to 1. And so if I want to find what a is, I just divide. So therefore, a is equal to 6 over 125. So here this 125 over 6 is just me subbing in 5 and 0 into my into this definite integral. Okay, so I've got this value of a is equal to 6 over 125. So this first part, this was just what we did in the last lesson when we checked whether or not a function was a valid probability density function. Okay, part B. Express p of x is less than 3 is as a definite integral. Okay, now for this one, this is a little bit trickier. Notice here, it's not less than or equal to, it's just less than. So what I need to actually do is I need to break this up a little bit. So what I need to do is I need to go, okay, for part B, if I want to find the probability of x is less than 3, well, what do I need to do? Well, this is just going to be the whole probability, 1, minus the probability of x is between 3 and 5. So here, this one is actually not quite the same because here I don't have that less than or equal to. So notice here in my definition, it's less than or equal to. So what I need to actually do is I need to go, okay, if I want just less than 3, I need to take my whole probabilities, all my total probability, and subtract the bits that I don't have. So here, this is just the integral, this particular 3, between, our random variable is between 3 and 5. So here, this just gives me 1 minus, and we don't actually need to evaluate it, the integral of 3 to 5 of ax 5 minus x dx. So that's what I need to do for this particular one here. This one we had to actually notice that this isn't quite the cumulative distribution function. This is actually a little bit different. And so we had to actually rethink how we thought about this question. Okay, that's this example. Let's have a flip over the page. Okay, over the page. Here we go. The probability density function f is given by this function. So here, this is our probability density function. And we want to find, if you have a look, the median m of this function satisfies the following equation. Now, how do we find the median? Well, if we want to find the median, what we want to do is we want to actually get the cumulative distribution function. So our cumulative distribution function tells me what probabilities of scores, what is the probabilities of the scores up until a particular score. So here, if you remember from the previous page, that is the integral from a to x of f of x dx. That was from the previous page. Now the median is just the middle score, right? So if it's a middle score, that means that 50% of my scores have happened. So what I want this answer to be equal to is, I want this to be equal to a half. So the way I'm going to answer this question is I'm going to set it up so that it is equal. So I'm going to set this up like so. So here, my probability, we want the probability of x is less than m. And so m is just my median score. And so that is from a to m. Now m is at the top here, but we want to find the value of a. A is the lower boundary of the of my scores, and so in my probability density function, it is just 0. So here I'm going to put from 0 to m of 1 over 2 8x minus x cubed dx. And so let's just evaluate this just to make it just to help us out in the next step. So that's going to be 1 over 12 8x minus x cubed dx. I'm just taking out the 1 over 12 just to make it a little bit easier for me. And this just becomes 4x squared minus 1 over 4x to the power 4, m0. And so this becomes 1 over 12, 4m squared minus 1 over 4m to the power 4. Now, in order for us to have the median, we need to let this thing be equal to a half. So I'm just going to go, okay, therefore, for m to be the median, we need to have this being equal to half, because half is where half of the scores are for my cumulative distribution function. So here, this is going to be half 4m squared minus 1 over 4m to the power 4 is equal to a half. And I'm just going to start simplifying stuff. So I'm going to multiply that 12 over, so I get 4m squared minus 1 over 4m to the power 4 is equal to 6. And I want to get rid of that 4 at the bottom, because notice here all of my answers from this multiple choice, the coefficient of m to the power 4 is 1. So I'm just going to multiply everything by 4. So I get 16m squared minus m to the power 4 is equal to 24. I'm just going to rearrange this. So this gives me negative m to the 4 plus 16m squared minus 24 is equal to 0. So let's have a look if any of my answers are this. Well, it's not this one, it's not this one, it's not this one. So it's one of these two. Well, it's not equal to 0.5, so it's not going to be this one. It has to be this one here. And if you have a look, well, that's just the positive version of that. I can just multiply this whole thing by negative 1. And here, my final answer is E. Okay, so that's how we solve this question over here. If we want to find the median, well, we look at the cumulative distribution function. We just want to get half of our scores. Half our scores is just where we let our cumulative distribution function, this guy here, be equal to a half. Okay, this next question I'm going to actually leave for our online lesson tomorrow. Online lesson, and the same with the one over the page. What I want to do is actually have a go at this question over here. This question. Okay. A bid made at an auction for a real estate property in millions of dollars can be modeled by the random variable x with a probability density function as following. Okay. So, for this one, we've got our probability density function here. Part A, show that the value of k is equal to 1 over 27. Now, just like we did in the previous example, in order for us to have a valid probability distribution, probability density function, we need to have this, the integral of our probability density function over the domain to be equal to 1. So what I'm going to say here is the integral of k 16 minus x squared dx, and the domain is from 1 to 4. So from 1 to 4 is equal to 1. Is equal to 1. It needs to equal to 1. So let's just integrate this. So on my left hand side, I'll take out the k, and that's still equal to 1. And then we can now integrate. So here this just gives me k integral of 16x minus 1 over 3x cubed for 1 is equal to 1. And I just sub in my values here. So here I'm going to get 64 minus 64 over 3 minus 16 minus 1 over 3 is equal to 1. And this, I believe, gives me 27 altogether. So that's 27k is equal to 1. So therefore, k is equal to 1 over 27. Okay, part B. Now, part B is where this important note happens. So part B, find a cumulative distribution function. So we want to find a function, that cumulative distribution function that we talked about. So here P of x is less than or equal to x, our score is equal to the integral of a to x of f of t dt. Okay, now here, what we need to be careful of is what happens outside the domain specified. Remember, the cumulative distribution function represents the probability of x is less than or equal to our score. So we need to be actually really careful of scores that are above our particular score. Okay. Second thing is, don't forget the constants of integration. Constant, and there might be more than one. So constants of integration. So what we're going to do is we're going to actually integrate our particular function here. So here, what I want to do, so the p of x is less than x is equal to the integral of, now what we have here is a to x. So what I'm going to have is, this is a to, a is just a lower value, so it's going to be 1 all the way up to x of my particular function here. So k 16 minus x squared dx. So here, just like we did in the previous step, I'm just going to integrate this guy here. So I'm going to take out the k just to make it easier. And what we did, we already did the integration. So this is just 16x minus 1 over 3x cubed. This is x and 1. And when I sub in x, I just leave the x in there. 16x minus 1 over 3x cubed. But when I sub in the 1, I'm going to minus 16 minus a third, which I believe gives me 47 over 3. Okay. So my probability distribution function is going to be equal to, probability density function, not probability density function, my cumulative distribution function is going to be equal to 1 over 27. I'm subbing in my value of k. 16x minus 1 over 3x cubed minus 47 over 3. Now, notice here I've got a couple of fractions inside my bracket. I'm just going to get rid of them by multiplying everything by 3. So if I actually going to take out that 3, so I've got 1 over 81, 48x minus x cubed minus 47. So what this means is, for my domain, for my probability density function, p of x is less than x, it's going to be equal to 0 for x is less than or equal to 1. And it's going to be equal to this function, 1 over 81, 48x minus x cubed minus 47, for anything between x is 1 and 4. Now the other condition was, what happens if it's outside of 4? Now after 4, well, the cumulative frequency up until that point, well, after we've reached 4, is just going to be 1. We've already got our total our total probabilities all together there. So 1 just represents the whole. So after 4, it's just going to be 1. And so that's what our probability, our cumulative distribution function is going to look like. So let's have a look at the third part. C, find the probability that a bid of more than $3 million will be made. So find the probability that a bid of more than $3 million will be made. So if we want to find the probability of a bid that's greater than 3, what we need to do is we need to think of it in the opposite way. Well, if I have my scores being from 1 to 4, and if I want all the scores from 3 greater than 3, so everything above here, well, that's just the probability of our random variable being between 3 and 4. So this is just equal to 3 and 4. And so all we need to do here is we just need to integrate our probability density function between 3 to 4. So here's going to be the integral from 3 to 4 of k 16 minus x squared dx. And so we've already done this integration a couple of times now. So this just gives me 16x minus 1 over 3x cubed. And I'm substituting 4 and 3. And this will just give me 64 minus 64 over 3. I'm subbing in these values, minus 48 minus 9. And as a final answer, I believe this gives you 11 over 81 or 0.1358. So there we go. That is how we answer these questions with our cumulative distribution function. So here, This one was a little bit trickier. So the thing that we needed to notice was for our cumulative distribution function, what we do is we just integrate from our bound, but we make the upper limit x, and we get this function here. So this function tells me what the cumulative distribution is for all those values between 1 to 4. And the other thing that we needed to note is after we've reached 4, well, we've already got all of the probabilities. So what that means is we've got all the scores after then is going to equal to 1. Okay, so that's how we answer this question here. I'm going to leave this next one for our online class as well. And actually, I'm going to pause the video. Actually, no, I'm going to keep going. I'm live. Okay. Next thing we're going to talk about. We're going to talk about a uniform distribution. Now, a uniform distribution's probability density function is constant. So what this means is if I have an event or a random variable where it's got equal probabilities the whole time, for whatever random variable, for whatever thing it is, it's just going to have a constant probability. So here, my y value is just going to be constant the whole time. So that's what a uniform distribution is. So here, let's have a look at these two questions. Given each of the following for x values between 0 to 10, so this is our domain. We want to find the value of k such that this is the function is a probability density function. We want to find the corresponding cumulative distribution function, and then find the median and quartiles. So let's go through how to do this. So for the first one, the first part is actually quite simple. Finding k's and make the function a probability density function. As we said before, in order for our function to be a probability density function, we need if we integrate it over the domain, it needs to equal to 1. So here, when I do that, I'm going to get kx. I'm going to have 10 and 0 is equal to 1, and so 10k minus 0 is equal to 1, 10k is equal to 1, k needs to equal to 1 over 10. Okay, part 2 for this particular one. Part 2, I want to find the cumulative distribution function. So here they call it f of x. Now, for what we've said this lesson is the cumulative distribution function is just the integral of the lower part of my domain, so 0, all the way up to x of my probability density function. So here, that is what this function is going to look like. So here, this is going to be kx, subbing in x to 0 to x. And so I get kx, or just 1 over 10x from what we did in the last part. Okay, that's that so far. Now, the third part is I want to find the median and quartiles. Now, when I want to find the median and quartiles, what we can do is we can use the cumulative distribution function. If you remember, the cumulative distribution function tells me what the sum of all the probabilities up until that point are. And so what we can do here is we just need to let this be equal to the values for those medians and quartiles. So let's start off with the median. Well, the median is just 50% of my scores. So what I want to do is for the median, I just want to let my cumulative distribution function be equal to a half. So here I'm going to write 1 over 10x is equal to a half. So therefore, my median is just going to be 5 because I multiply that 10 over. So from there, we just need to do the same thing for our quartiles. Now, first quartile is when we have 25% of the scores, or 1/4 of the scores. So here, f of x is going to be equal to, it's not going to be a half, it's going to be a quarter this time. So here, I'm going to have 1 over 10x is equal to a quarter. So x is equal to 5 over 2. And the same thing for the third quartile, so upper quartile. So upper quartile this time is going to be f of x is equal to 3 over 4. And so there, here we go to the same step. 1 over 10x is equal to 3 over 4. So x is equal to 15 over 2. Okay, so that's how we can actually use our cumulative distribution function to help me find our medians and quartiles. Let's just do the same thing, but with our following part. Now, this one is a little bit different. So here, this is f of x is equal to kx. Let's just check the value of k in order for this to be a valid probability distribution. So if I integrate from 0 to 10 of k of x, that needs to equal to 1. So here, I'm going to get k... actually, I'm going to move the k out. So it's just going to be integral of half x squared. 0 to 10 is equal to 1. And so that means that 50k needs to equal to 1, so k needs to equal to 1 over 50. So that's just me integrating, substituting those values in, and rearranging and solving for k. Now part 2, I want to find the cumulative density function. So big F of x is going to be equal to the integral of the lower boundary. So here 0 all the way up to x of my, my probability density function. Okay, and we've already done that integration. So here this is just integrating from half x squared, x and 0. And so here this just gives me half kx squared, and we can just sub in the value of k. That's just 1 over 50. So here I'm going to have 1 over 100 x squared. Okay, and just like we did before, to find the medians and also the quartiles, I just need to let this be equal to a half, quarter, and also 3/4. So here I'm going to have, for part 3, for the median, 1 over 100 x squared is equal to a half. So therefore x squared is equal to 50. Therefore x is equal to plus or minus square root 50. But because x has to be between 0 to 10, we need to take the positive value. So this is going to be just the square root of 50, which is 5√2. First quartile, we're doing the same thing, 1 over 100 x squared. But instead of letting it be equal to 1 over 2, it's going to be equal to a quarter. So x squared needs to equal to 25. So therefore x needs to equal to 5. And the final one is the upper quartile. And just like we did in the previous question, we're going to let that equal to 3 over 4. So x squared is equal to 75. And so therefore x is equal to square root 75, which I believe is 5√3. So that's how we can find quartiles and medians from our cumulative distribution function. In particular, this is a what's called uniform distribution, and so that is a little bit neater. Now I'm going to have a go at this question. Let me think about this. We're going to have a go at this question together in class as well, and the same with the one over the page. What I want to actually talk about is distributions with. Actually, let me think about this. I want to just quickly talk about this part here before we end this video. So this part here. A probability distribution function may have an unbounded domain. This will result in a improper integral. Now, an improper integrals is something that you cover in first year uni, but what we have here is you can also have an unbounded domain. An unbounded domain just means that your probability density function goes from negative infinity all the way up to infinity. And so here, the way that we do this is we just need to take a limit as a goes to infinity of both ends. And it's as long as this is equal to 1, your probability density function is a valid probability density function. So let's have a look at this example underneath. A, find the area under the curve y is equal to 1 over x squared for from the domain from 1 to a. Okay, so let's have a go at this. If I want to find the area, what I want to do is set up a definite integral, and here they tell me from 1 to a. So I'm going to go 1 to a of 1 over x squared dx. Okay, now I need to integrate 1 over x squared. That's just x to the power negative 2. So when I integrate this is going to give me negative x to the power negative 1 from 1 to a. And like we do when we normally do this, we just substitute our values. So get negative a to the power negative 1 plus 1 to the power negative 1. And so this just becomes negative 1 over a plus 1, or I'm just going to write it as 1 minus 1 over a. 1 minus 1 over a. Okay. B. Take the limit as a goes to infinity and show that y is equal to 1 over x squared. X is greater than 1 is a probability distribution function. So let's just take the limit as a goes to infinity. So as a goes to infinity, what do we notice? From the first part, the area goes to 1 minus 1. So the area was 1 minus 1 over a. Now if a goes to infinity, what happens? Well, the big area goes to 1 minus 1 over infinity. Now if a just becomes bigger and bigger and bigger and bigger, that just means that this area this number here goes towards 0. So that means that my area, if I sub in 0 here, just goes towards 1. So therefore, what I can say here is, therefore, if I take the integral of from 1 to infinity of that particular function, 1 over x squared dx, that will just be the limit as a goes to infinity of integral of 1 to a of 1 over x squared. And what we showed in the previous part was that this has an area of 1. So that means that y is equal to 1 over x squared is a valid probability distribution function. Okay, cool. That's the first part. The next part is I want to find the corresponding cumulative distribution function. And so here, this is actually quite easy because we've actually done it in a previous step, but you might not have noticed it. We want to find the cumulative distribution function. And so here, what we want to do is we want to integrate from the lower boundary 1 all the way up to x of my function, 1 over x squared dx. And so here, this is just me substituting it, x and 1 into this particular guy here. And we've actually done it over here. And so all I need to do is just replace a with x. So 1 minus 1 over x. Okay, so that's it for cumulative distribution functions. In our video, we're going to talk about this a little bit more, but let's just do a quick recap of what we did today. A cumulative distribution function. Let me just go to the notes ahead. A cumulative distribution function. Oh, that's previous lesson. Still can't find it. Where am I? A cumulative distribution function, 15th attempt, is a signed area function. And so what this actually tells me is what is the probabilities of all the scores up until the given score that we looked at. And so what we want to do here is just take the integral from our lower boundary up until the given value that we're looking at. And so here we've done a few questions where we actually needed to apply that into different scenarios. And the other thing that we needed to do was if we wanted to find the medians or quartiles, what we need to do is let our cumulative distribution function be equal to a half for our median, a quarter for our lower quartile, and 3/4 for our upper quartile. So hopefully that helps in preparing you for our online lesson. We're going to have a go at a few more questions on this. There should be a couple questions posted for you to have a look at if you want to get some practice. But until then, Year 12s, I hope you guys are staying safe. Actually, let me try that again. As always, Year 12s, stay safe, stay healthy, stay wonderful, and I'll see you guys in our online lesson. Bye.